less than 39. You know how in distance you have centimeters and inches, and it's two different systems, but they give you the units of distance or a measurement. In temperature, you have degrees and Fahrenheit. You have Fahrenheit degrees, Celsius degrees, you have Kelvin, but they all measure temperature, right? Angles are measured. What do you measure? Up to now, you've measured angles in what units?
Degrees.
Degrees. That's what you're used to, right? Degrees. And it's a circle is 360, and half a circle is 180, and so on, right? Do you remember what pi is?
3.14.
Yes, because it's a ratio, but it's a ratio between what?
The little bit that doesn't in the circle, like the end, doesn't finish. So it's like.
It does finish. It does close up.
But it's not like an exact number.
It is. That's not why it's not an exact number. But pi is the ratio of something to something else. The question is what? Look at it there.
Where is it?
What's pi? It's the ratio of the circumference to the diameter.
Diameter, yes.
Okay? Of a circle. Circumference. So, just as degrees is a circle, it's 260, well, pi is also related to a circle, right? In fact, that's the whole reason of being of pi. Just so you know, pi, this letter, didn't come into being until Euler named it pi in honor of the Greeks who discovered this ratio, and the Greeks discovered that the ratio between the circumference and the diameter was the same for every single circle. It didn't matter what size it was. The ratio was always the same from the circumference to the diameter. Anyway, why am I telling you this? Because that way you can figure out that pi, since it's related to the diameter, it's the circumference is the whole thing, and the diameter is half of it. Pi is equivalent to 180 degrees, right? Because it's only half a circle. Circumference divided by diameter, it's half a circle. Therefore, 180 degrees. This, since we have to give it a name, when it comes to a different system of measuring angles, pi is in radians. So pi radians is equivalent to 180 degrees. That's simple, okay? So, how much would 360 degrees be?
2 pi.
2 pi radians. Nothing really hard there, right? So, let's do something. If they give it to you, so if I give you the cosine of pi halves minus the sine of pi thirds, what would that be? First, go.
Would it pi be 180? No.
It is.
So it's cosine of 180 divided by
90.
Cosine of 90 minus sine of
60.
and then you know what to do. It's really, really easy. That's it for this one. There's another topic. So, just one simple thing. What if they ask you to find, look at example 39.4. It says, the latitude of a point on Earth, all of those are a bunch of words. They say something really simple. The latitude of a point on Earth is the degree measure of the shortest arc from that point to the equator. The latitude of LA is 34.04 north of the equator. How far is it? Okay, so they're telling you that LA is the diameter of Earth is 7,920 miles. So the radius is how much? Half of that, right? that would be 3,960 degrees and 60 miles. That's the radius of Earth. And LA is 34.05 degrees above. How do you find the distance, this distance from here to here, to the, how do you find this distance? Knowing the degrees.
It's 34.0 times 0.5 times 2. All that.
Why times 2?
Because side of the circle, the angle of the side is.
No. You're finding this distance, and this distance is a fraction of the circumference.
Tangent of 34.5.
Is it
Nope.
a sector thing?
You've done this before. Go ahead.
34.05 over 360.
Of course. This is nothing new. You should know how to do this. You're finding the distance, which is again, it's the fraction of the circumference, right? Because it's the distance outside of the circle. And there's another big circle here. And you're finding this little portion. And this little portion is 34 out of 360 times the radius. Times 2, which is what she said, 2 radius, right? Oh, I didn't have to divide it, times diameter. 7,920 miles is the diameter. Okay? So, times the diameter. Because this is pi. Pi times the diameter, right? That's the circumference. No? Yes? Maybe.
No.
Let's do another one.
Wait, minus what?
Let's do another one.
What times?
Theo measured the angle between the base of the building and the top of the building. And it was 6 degrees. 0.6 degrees. Theo was 4,000 feet from the base. How high is the building? This is a building. How high is the building?
0.06.
0.6 divided by 360
360 times
times
4,000.
4,000
times. Very good.
and that's the answer.
Then that's the answer. Well, no, you have to put it in the calculator and find the answer, right? Okay. So nothing new here, right?
Maybe done the.
I'm not gonna erase. And I need to go on to the forms of linear equations. So, linear equations. So far, we've worked with this one and this one only. Right? This one is called the slope-intercept form of a line. Slope-intercept form. Why do you think it's called the slope-intercept form? Because it's got the slope and the y-intercept. Okay? Hence the name slope-intercept form. You've seen this one also. Because from this one, let's say you have something like this. You go from this one and you turn it into this one. You leave the y by itself, right? This one is called the general form. Of a line, right? We're talking about lines. There's another bunch of forms that might be helpful. And they're on page 282 if you want to look at them. There's the double intercept form. This is the double intercept form because A and B would give you the intercepts with the X and Y axes respectively. So, double intercept form. If you get this, let's say you have x over 2 plus y over 1, no, over 4 equals 1, you already have 2 points that you can put. The points would be 0, 2 comma 0, and this would be 0 comma 4. You have 2 points, you can just draw the line if you have to graph it, if you have it like this. Because these are the 2 points on, these are the y and x intercepts. Okay, does that make sense? Then we have the point slope form. Y minus y1 equals m. Point slope form. Remember, there's some problems where they give you a slope and a point. This gives you the equation of the line directly. You just substitute the point in y1 and x1, you've got the slope, and then you've got your line, the equation of your line, okay? You no longer have to find the slope and do everything that you did before. And the last one is the 2-point form, which looks like this. Which is basically this one, but they substituted the 2 points for the m, for the slope. Right? You recognize that. This would be the slope. But they give you 2 points, so you just stick it in everywhere, and now it becomes a formula. Yeah.
So wouldn't, on the last parentheses, wouldn't it be x minus x1?
Yes, it would be, but I made a mistake, so thank you for correcting me. Yes. So this is the 2, it's the only way of keeping you guys awake. 2-point form. 2-point form. Okay? So, write, they give you any one of these forms and they ask you to go from one form to another. Do you want me to do one or we're good there?
Do one.
Let's do one.
Do one? Okay. Can I erase?
Yes, me.
Again, if you didn't catch that, you have it in your book. And they tell you to write it in general form. What do you do? First things first, right? The 15, multiply times 15 because it would be your common denominator, so you've got 15y equals minus 7 times 5 x plus 3, right?
Yeah.
And then you would pass this to the other side, so you've got 35x
So it's
plus 15y
minus 3.
minus 3 equals 0. There you go. That's the general form. That's simple. Questions?
No.